I've always had this experience as a science teacher that when students are being asked to state Newton's second law of motion mathematically, about 90% of such students will say that F equal to ma, that is the force is equal to the mass times the acceleration. So guys, this formula is true. At the same time guys, it is sometimes misleading. Here's why guys. If you consider a rocket that is being launched into deep space, or better still into space guys, we can say that the rocket loses mass continuously. One of the very important reasons you can account for this loss in mass is that the rocket uses fuel, and as time goes on, the fuel of the rocket keeps on decreasing. Great. So friends, in such a case now we can tell that the mass of the rocket is not a constant, and guys, the formula F equal to ma guys is not correct, or better still guys, this is misleading at this point since the mass is not constant. So guys, what I'm trying to say is that the formula F equal to ma is true when the mass is a constant. That is great. When the mass is a constant guys, the force obviously is a constant, and the car and the rocket in this case guys is going to be accelerating. So friends, the Newton's second law of motion in its condensed form states that the rate of change of linear momentum of an object is proportional to the net or applied force and takes place in the direction of the force. That is the statement of the law guys. Now friends, let's look at the mathematical part of the law as it states. So if we can transform all of this, our writings, into an equation which says that F is directly proportional to what guys? The change of momentum, that is the derivative with respect to time of momentum, since they said it is the rate of change of momentum. Great. So for instance, in this case, our momentum, as you all know, is what mass times velocity, right? So this becomes F equal to, if we can remove the constant of proportionality, which by replacing it with equal to, then we have k, then momentum is mass times velocity, we are going to have d by dt of mv. So for instance, in this case now, we have a product of two functions. We are going to differentiate them by applying the product rule of differentiation. So it simply states that we are going to differentiate one, keep one constant, then differentiate the other and keep the other constant. So we have k into, we keep the mass constant, differentiate the velocity with respect to time, we have dv by dt, plus keeping the velocity constant, differentiating the mass with respect to time, we have dm by dt. Friends, this constant has been experimented and seen to be 1. Oops, friends, what is dv by dt? It is the acceleration. Great. So this our formula now turns out to be F equal to, we have ma plus v dm by dt. Great. Friends, let's do some analysis. Friends, we can say that the formula F equal to ma is true when the mass is constant, and it is false when the mass is not constant. Now friends, the formula F equal to v dm by dt is true when the mass is not constant. That's great. So friends, thank you so much for watching the video. Thank you so much, and leave your worries in the comment section down below, and I'm going to reply to it as soon as possible. Thank you and have a blessed day.